All right, here's the key for the practice exam. Start with number 1. This could be thought of as the absolute value of x minus 0 is greater than or equal to 4. So these are all the points that are more than 4 or more units away from 0. So that looks like there is 0, and 4 units that way, there's 4. 4 units that way, that's minus 4. And so the points that are 4 or more units away from 0 would be everything out here or everything over here, including the endpoints. All right, the second one, this can be thought of as the absolute value of x minus a minus 2 is greater than 4. So on the number line, the points of interest are minus 2, 2, 3, 4 that way gets us to 2, 1, 2, 3, 4 that way gets us to minus 6. The distance from 2 has to be more than 4, so it's out here beyond 2 or over here beyond minus 6 to the left of minus 6. If you want to do it algebraically, it says to sketch the graph, so eventually you have to sketch the graph, but if you'd like to do it algebraically, you have x plus 2 being less than minus 4, or x plus 2 being bigger than 4. So the absolute value of x plus 2 is greater than 4, which means the thing in absolute values is either bigger than 4, less than minus 4, or greater than 4. That's what it means for that thing to have an absolute value greater than 4. So subtract 2 from both sides, you get x is less than minus 6. Subtract 2 from both sides of this one, you get or x is greater than 2, which is what we've graphed here. Here, probably easiest to do this as a conjunction algebraically. So it looks like this. If you think about the number line here, things whose absolute values are less than 12 have to live in between 12 and minus 12. But what lives in between here is not x, but 3x minus 2 lives in here. So that means that minus 12 is less than 3x minus 2 is less than 12. Add 2 to all three pieces. You remember when you add 2 to a negative, you're heading back towards 0. So that's minus 10. On this side, it goes away from 0 the other way. That's 14. Divide through by 3, you get minus 10 thirds. It's less than x. It's less than 14 thirds. Or if you like, you could draw a number line, graph it that way. If you try to do it as a, graphically, it's a little tricky, but it's doable. It's the absolute value of 3 times x minus 2 thirds is less than 12. If you distribute that, that's 3x and that's 2, so that works out. So it's, and then you pull the 3 out. Be very careful about pulling things out of absolute values. I see a lot of you doing it for subtraction and addition. That's never a good idea, but if you're multiplying by a positive number, you can get away with it. So this x minus 2 thirds less than 4. So it's a set of all points that are within 4 units of 2 thirds. So there's 2 thirds right there. Otherwise, if I go 4 units this way, so 2 thirds, 4 equals 12 thirds. So if I add 12 thirds to 2 thirds, I get 14 thirds. Subtract 12 thirds from 2 thirds, I get minus 10 thirds. And so it's everything in between. Open circle, graph. That's another way of getting the same answer. All real numbers at least 3 units away from 4. So we start with a number line and centered around 4. So it's relative to 4. And there's 4. it has to be at least 3 units away from 4. So we go 1, 2, 3, 1, 2, 3. So it's everything at least means it can be 3 or more. So it's out here or out here. That's a 1, that's a 7. In terms of absolute values, that means that x has to roam in this range here. So the distance between x and 4 has to be less than or equal to 3. That's the statement in terms of absolute value. That's an absolute value inequality that captures that interval. The distance from x to 4 is at least 3 units. Oops. Find the slope of the line. Pick any 2 points on the line. I'll just pick the 2 that are highlighted here. Doesn't matter. Be careful about interpolating, though. I wouldn't mess with that point, for example. Try to pick ones that are right on an obvious intersection of 2 integers. So this is 1, 2, 3, 4, 5, 6, 7, 8. 8 blocks east and 1, 2, 3, 4 blocks south. As I move east along this road, I'm traveling south. So I know it's negative 4 over 8, which is minus a half. There's your run. There's your rise, or in this case, it's negative rise. If you want to do it in terms of points, you could take minus 5, 1, which is a point on the left, and 3 minus 3, which is a point on the right, and you could find the slope that way. 1 minus a minus 3 divided by minus 5 minus 3, which would give me 4 over minus 8, which is minus a half. Down here, 2, 1 would be there. Minus 4 minus 2 is there. That's 1, 2, 3, 4, 5, 6. 1, 2, 3. So the line goes, slope is positive because as I drive east along this road, I'm going north. So it's rise over run. So for every 6 units over, goes up 3. That means m is a half. Or if you prefer, you can use the formula. y2 minus y1 would be minus 2 minus 1 over minus 4 minus 2, which is minus 3 over minus 6, which is a half. If y is 0, x is 2. If x is 0, y is minus 1. So 2, 0 is here. 0 minus 1 is here. That's a slope of over 2 up 1. So it looks like the slope is m equals 1/2. Or if you prefer, again, you can use the formula. 0, the slope is y2 minus y1 would be 0 minus a minus 1 over 2 minus 0, which is 1/2, which is what we got from the graph. I just want to be careful. X and Y have to be positive integers, so it's probably easier to attack this guy with the table. Start with the smallest positive integer. 0 is not positive, so 0 is out. The next integer is 1. If I put 1 in here, I get 2. 2 plus y is less than or equal to 4. Y is 1 works. Y is 2 works. Y can't be 0. It's positive. 0 is not a positive integer. So 2 times 1 plus 2 is equal to 4, so it's less than or equal to 4, and 1 times 2 times 1 plus 1 is also less than 4, less than or equal to 4. So those 2 points, 1 goes with 1, and 1 goes with 2, if this is x, and that's y. And nothing else works. If you go to 2 for x, you're already up to 4, y can't be 0, so that's out, and there's no other way to get there. And you can't go negative, so that's it. If you draw the line, a lot of people are going to draw the line, and it's useful. If x is 0, y is 4, and if y is 0, x would be 2. So it tells you that the solutions are going to be on this line, or actually to the left of it. You can tell because it's solid, because less than or equal to. But you can tell it's to the left because you put 0, 0 in, here's 0, 0 here. Put that number in, you get 0 plus 0 less than or equal to 4, which is true. So you know it's points on that side. So if we were looking at the entire coordinate plane, it would be all these points over here, right? But it's not a coordinate plane. It's only the positive integers. So that means it can't be on this axis. It can't be on this axis. It has to be to the right and above, and then inside. So it has to be inside this triangle. And these are dashed, I guess, because it can't be 0. So these would be dashed, and this would be solid. So the line does tell you something. It tells you that it has to be inside that triangle. But it has to be where these grid lines intersect to get whole numbers. And there are only 2 of those. Those are the ones we came up with originally. So don't draw the line. A line suggests there's an infinite number of solutions. They're not an infinite number of solutions. They're just 2. There they are. You might want to even circle them just to make sure that you realize there are only 2 of them. Don't connect them. That's it. 2 solutions. 1, 1 and 1, 2. That's it. Here, Alphonse says $1.40 in dimes and quarters. So if D is the number of dimes, don't just say it's dimes, because then I don't know if you're talking about the value of or the number, the quantity. This is quantity of quarters. So each dime is worth 10 pennies, and each quarter is worth 25 pennies, and altogether we have 140 pennies. We can divide these all by 5. That would give me 2D plus 5Q is equal to 28. A little bit easier to work with. Doesn't really matter. You can go either way. Solutions. Let's go with solutions again. D and Q, it's often easier to go with the bigger number, the bigger denomination, quarters. So if we have no quarters, we can get to $1.40 with 14 dimes. If we have 1 quarter, there's no way we're ever going to get to $1.40 with dimes. Your quantity of money is going to end with a 5, so that's not going to work. So we'll skip that, and we'll go right to 2 quarters. 2 quarters is 50 cents. We need 9 more dimes to make it. And now we see the pattern. For every 2 quarters we go up, we go down 5 dimes, not surprisingly. So that means we can go 1 more set here. That's 4 quarters, and that's 4 dimes. And the next one would give us a negative number of dimes, so we're done. So there it is. There's 3 solutions. You can pick to choose D and Q on either axis you like. It doesn't matter as long as you're consistent. So if we call that the D axis, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14, 0. We go down 5 dimes, 2, 3, 4, 5, up 2 quarters. 1, 2, 3, 4, 5 dimes, up 2 quarters. There are your 3 solutions. Again, don't connect them. That suggests that you have more solutions. Nobody's interested in fractional dimes and quarters. It's got to be whole numbers of dimes and quarters. So there it is. Again, don't connect them. And the slope of the line then we get by looking at, it's 1, 2, 3, 4, 5 over, down 2. So the slope of the line is minus 2 quarters for every plus 5 dimes. English language sentence, always start with the bottom when you're talking about slope. So if I add the denominator 5 dimes, I take away 2 quarters. So rise, the run is 5. If I add 5 times, I lose 2 quarters. That's a perfectly sensible statement about money that would make sense to even your little sister, but it's actually also the slope of the line. Express the solution set in whatever form you prefer. I have to get this absolute value by itself. I can't do it with the 4 and the 1 in the way. I can't break up the absolute value into something easier to deal with algebraically. So let's subtract the 1 and divide by the 4. Now I can work with this. So it's it's an absolute value of something is greater than 3/4, which means it's a disjunction. It's either this thing is absolute value is being evaluated is either less than minus 3/4 or it's greater than 3/4. This one, I just add 1 to both sides, gives me 2x over 3 is less than, if I add 4/4 to minus 3/4, I get 1/4. And now I can multiply through by 3 over 2. That makes this side x and this side 3/8. Or, same process over here, add 1, this gives me 4/4 to 3/4, gives me 7/4. Now I'm going to multiply through by 2/3. That gives me, 3/2. 21 over 8 is less than x. So x is either bigger than 21/8 or less than 3/8. And this is doable graphically too, but I think this is the easiest way to do it. So I'll leave it at that. And lastly, the extra credit. This is tough. X minus 3 is one of two things. I'm sorry, the absolute value of x minus 3. It's either itself or the opposite of itself. So for example, if x is equal to 5, the absolute value of 5 minus 3 is just 5 minus 3. Not a problem. If I go below 3 though, for example this, I can't just do this because that's positive and that's negative. So I have to slap a negative sign in front of it. Now it's true, right? This is 2 and this is minus a minus 2. They're equal. So if x is greater than 3, I can just write it this way. If x is less than 3, I just have to switch the sign. So I can get rid of the absolute values if I know whether x is bigger than 3 or less than 3. Similarly, if I'm dealing with 2x, absolute value of 2x is equal to 2x if x is positive, right? The absolute value of 2 times 5, for example, is equal to 2 times 5. It doesn't matter. As long as x is positive, I don't need the absolute values. If x is negative, then I have to multiply 2 times, I have to take 2 times negative 5, which is negative, and slap a negative sign in front of it to make it positive. So if x is negative, I have to go to the opposite. So if absolute value of 2x is equal to one of two things, it's 2x if x is greater than 0, and it's minus 2x if x is less than 0. Now I can put all that together to solve the inequality. It helps to have a number line to kind of guide us here, so let's draw a number line here. And mark the points that matter. So we're interested in when things are bigger or less than 3, so we'll mark 3. And we're interested in things that are bigger or less than 0, so we'll mark 0. And then in this range in here, everything is positive. So absolute x minus 3 is just equal to x minus 3. So I can get rid of the absolute value signs. I'm rewriting this now without the absolute values. Is less than 2x is also positive, so I can just solve that. In this range in the middle, now I have this thing is bigger than, x is bigger than 0, so this guy I can write as 2x. But over here, I'm now less than 3, so now I'm going to distribute, that's minus x plus 3. Is how I write that inequality. And then over here, less than 0, now this guy is switched and this guy is switched. So I rewrite this, it looks like minus x plus 3 is less than minus 2x. Now I have 3 different ranges to work in. So let's start with this range out here. I can just solve the inequalities for each one of them. So for this guy, I just subtract x from both sides. That gives me that. X is greater than minus 3. But this is only true, in this range we're dealing with numbers bigger than 3. So, and x is greater than 3. So if x is bigger than negative 3 and it's also greater than 3, that results in just x, logically, it's just x bigger than 3. So we know x bigger than 3 is going to work. In this range in the middle here, I've got a minus x here and a plus over here, so I'm going to bring this minus over here and call this 3x. And then I'll leave the 3 over here. Divide both sides by 3, I get x is greater than 1. But here we're only dealing with numbers between 0 and 3. So if x is simultaneously greater than 1, but between 0 and 3, that means we're talking about 1 less than x less than 3. So numbers between 1 and 3 will work, not less than 1 in this range. And then lastly, we have this range over here. Let's see, let's move the negative 2x over here. So adding 2x to a negative x gives me x is less than, and I'll bring the 3 over here, x is less than minus 3. And this only applies to numbers less than 0. So if I put those two together, if it's simultaneously less than 0 and less than minus 3, that means x is less than minus 3. So if I put all this together into one answer, it's, I need another number line. We know that greater than 3 works, so there's 3. I know everything out here works. And I know between 1 and 3 works, so I know this works. And I know less than negative 3 works, so I know that works. And then I just have to check the endpoints. If you check all these points, these two won't work. So they're out because they're the endpoints of the interval, and it says strictly less than, so they're not going to work. You should test them to be sure, but they won't work. This one actually does work. If you put 3 in to the original inequality, if you put 3 in, x equals 3, I'm just going to evaluate this. I get the absolute value of 3 minus 3 is less than the absolute value of 2 times 3. That says 0 is less than 6. That's true. So 3 is in. So I can get rid of this open circle here, close it in, I can just, son of a gun, get rid of that open circle, just everything. So the answer is x less than minus 3 or x greater than 1.